Now, our next speaker is Matsuo Yutaka, professor in the Department of Technology Management for Innovation at the Graduate School of Engineering at the University of Tokyo. Professor Matsuo specializes in artificial intelligence with a particular focus on deep learning. He is recognized as one of Japan's leading AI researchers and serves as a chair of the Japanese government's Council on AI Strategies, which is responsible for guiding Japan's policies on generative AI. So please join me in welcoming Professor Matsuo.
Good afternoon, everyone. I'm very honored to have this opportunity to speak here in Tokyo Forum. Today, we will explore how generative AI is transforming our society and what future we can envision together. Let me briefly introduce myself. My name is Yutaka Matsuo. I'm a professor at the Graduate School of Engineering, University of Tokyo. Since my undergraduate years, I've been conducting research on AI, artificial intelligence, at the University of Tokyo. I also serve as chairman of the Japan Deep Learning Association, an external board member at SoftBank Group, and chairperson of the AI Strategy Council for the Japanese government. We are gathered here at Yasuda Auditorium, one of the most iconic buildings at the University of Tokyo. Last summer, this same auditorium hosted a symposium on generative AI titled "The Future Unlocked by Generative AI and Japan's Prospect." The event saw distinguished speakers such as former Prime Minister Kishida, SoftBank CEO Masayoshi Son, and other thought leaders discuss the possibility and challenges of generative AI. Today, I am delighted to continue that discussion. My talk will be divided into three sections. First, an introduction to my research lab and its activity. Second, a discussion on recent advancement in generative AI technologies. And finally, I will talk about what kind of future we aim to create with these technologies. Let me begin by introducing Matsuo Laboratory. Our vision of the laboratory is create intelligence and shape the future. Our goal is not only to conduct academic research, but also to create an ecosystem that fosters technological innovation and contribute to global progress. Our activities focus on four key areas: foundational research, education, social implementation, and incubation. With over 300 members, including students and staff, our lab is one of the largest AI research groups in Japan. In foundational research, we cover a wide range of topics from deep learning and generative AI to robotics. Lately, we have focused on researching large language models, LLMs, and robotics, which are crucial to the future of AI-driven systems. One of our most famous contributions is our early work in prompt engineering. We discovered that by simply adding the prompt, let's think step by step, the performance of large language models in solving math problems improves significantly. This simple yet profound discovery has been cited over 3,000 times and has inspired many others in the AI community. We have also been applying generative AI to robotics. In RoboCup at-home contest, which focuses on domestic service robots, our Tidy Up robot won first place in Japan and third place in the world competition. This achievement demonstrates our progress in combining generative AI with physical action. Now let me talk about education. In 2023, we offered over 30 educational programs focused on web engineering, data science, deep learning, and entrepreneurship. These programs are available to both University of Tokyo students and a broader audience, reflecting our commitment to nurture the next generation of AI talent. Our course enrollment numbers have been doubling each year. Last year, we had 12,000 participants, and this year we expect 25,000. Notably, many middle and high school students are also joining, indicating growing interest in AI among younger generations. In the summer of 2023, we launched one of Japan's fastest growing LLM courses with around 2,000 participants and double that number this year. Participants received free GPU resources, providing practical hands-on experience in LLM development. Next, I will talk about social implementation. Many of our students engage in joint research projects with companies. Matsuo Lab actively collaborate with industry leaders on projects ranging from autonomous driving to image processing, behavioral analysis, and forecasting. We are currently managing 30 to 40 such projects at any given time. The student initially work as member of these projects, gaining experience and developing their skills. Eventually, they grow into project managers responsible for negotiating with corporate partners and managing teams. Next is incubation. As students develop their skills, they often launch their own startups. So far, 27 startups have emerged from Matsuo Lab. Two of these companies, Parksha Technology and Gunoshi, have gone public, while two others have been acquired through M&A. The Parksha Technology, founded by one of our first Ph.D. students, Dr. Uenoyama, provides generative AI solutions, including communication services for enterprises. ELIZA, another notable startup, was founded by Mr. Soneoka, a graduate of Matsuo Lab. ELIZA specialized in advanced large language models optimized for Japanese and plays a significant role in KDDI's $1 billion investment in generative AI. Many startups are steadily growing, following the footsteps of those that have gone public. Some of our entrepreneurs are as young as 18 to 20, demonstrating the power of youth to contribute to society through AI. At Matsuo Lab, we integrate our 4 core activities: foundational research, education, social implementation, and incubation, to create an ecosystem, AI ecosystem, that is both productive and self-sustaining. Through these activities, we envision realizing the Hongo Valley initiative, which aims to transform the Hongo area, where the University of Tokyo is located, into an innovation hub similar to Silicon Valley. Our goal is to create a globally connected hub of technological innovation and entrepreneurship. Okay, now let's switch gears to explore the technological aspect of AI in detail. The latest generative AI advancements continue to surprise us. In February this year, OpenAI announced Sora, their latest video generation AI model, capable of creating high-quality videos from text, images, and even existing videos. In July this year, US-based AI startup Runway launched Gen 3 Alpha, a high-performance video generation model that can produce up to 10-second videos from text or images, suitable for commercial use. This development showcases how AI can generate realistic-looking content even for scenarios that are otherwise impossible. In last month, Meta released MovieGen, an AI model that allows users to generate realistic scenes from simple text prompts. This model also enables video editing through text instructions, showing how generative AI can empower creative processes. I would also like to highlight an example of how video generation AI can be used in Japan. By inputting two key frames, generative AI can generate the intermediate frames, making the animation production process more efficient. The technologies behind generative AI, specifically diffusion model and transformers, have been fundamental in making these advancements possible. To explain briefly, a diffusion model is used for generating images by adding and removing noise through a two-phase process. It starts by progressively adding noise to an image, and then a neural network is trained to remove this noise, ultimately reconstructing a clear image. Meanwhile, natural language processing has evolved significantly, especially since 2017, with the advent of transformer model. Transformers use an attention mechanism to decide which part of the input to focus on, which has revolutionized the way AI processes language. One of the key findings in AI research is the scaling law, which suggests that increasing the number of parameters in the model improves its performance. This is why big tech companies are racing to create increasingly larger models. An interesting phenomenon called grokking occurs in neural networks. After extensive training, the generalization performance of a model can suddenly improve, as if it deeply understands the task. This phenomena reflects a mysterious leap in comprehension that we are still trying to fully understand. Looking ahead, two major trends are emerging in AI research: AI agent and robotic foundation model. An AI agent is essentially a software system that autonomously performs specific tasks using AI. These agents are designed to interact with their environment in a human-like way, executing complex sequences to achieve defined objectives. Another direction is the development of foundation models for robotics. Robotics is currently undergoing a paradigm shift, moving from task-specific robots to general-purpose robots capable of handling a wide range of activities. At Matsuo Lab, we are also working on these robotic foundation models, enabling robots to understand their environment and execute complex actions based on natural language instructions. The goal of a robotic foundation model is to integrate diverse input, vision, language, and actions to generate appropriate behaviors and adapt to unknown environments. Our work on models like RT2 shows how AI can integrate vision, language, and action seamlessly. To develop an effective robotic foundation model, large-scale data collection is crucial. The RTX project, a collaborative initiative involving DeepMind and other institutes, including University of Tokyo, aims to integrate distributed robotics datasets for model training. And now we are planning to expand this effort. Now let's discuss the broader question: what kind of society do we want to build with AI? As generative AI advances, new risks emerge: security, ethical concern, misuse, abuse, hallucination. Addressing these risks require both domestic rulemaking and international cooperation. Countries around the world are advancing discussions on AI regulations. For example, the United States issued an executive order on AI safety last year, while Europe passed the AI Act, which categorizes AI systems by their level of risks. The Hiroshima AI process, initiated by Japan during the G7 summit last year, is the first international policy framework addressing generative AI. It aims to create safe and trustworthy guidelines for AI systems. In February this year, Japan established the AI Safety Institute (AC) to develop frameworks for AI safety. AC collaborate internationally, including the one in Korea, organizing summits and aligning guidelines across countries. The Japanese government also issued unified AI guidelines for businesses, outlining specific code of conduct for AI developers, providers, and users. The AI Regulation Committee, which I chair, established under the AI Strategy Council, is driving policy design discussion in this area. Japan is now moving towards creating AI use cases across various industries, including healthcare, robotics, and the public sector, leveraging the resources and infrastructure built so far. Japan is also facing a declining population, which necessitates raising productivity in various ways and solving social challenges effectively. As we think about the potential transformation AI could bring, it's important to distinguish between what we can do and what we should do. Let's consider some example. In the context of caregiving, the idea that robots could completely automate all aspects of care, including communication, might seem efficient. But is that really what we want? Instead, we should aim for a balance where robots handle routine tasks, freeing up caregivers to focus on the meaningful human aspect of care, providing emotional support and building connections. In education, while it is technically possible for students to learn entirely through generative AI, should we really replace the human element of teaching? AI should be used to assist educators, providing personalized support to students while enhancing the classroom experience. But some may argue that AI alone is sufficient, especially considering that many students struggle to fit into traditional school environments. However, rather than replacing teachers, AI should empower them to provide more tailored support and create a more inclusive learning atmosphere. When it comes to legal service, tools like legal LLM could make it easy for anyone to access specialized legal knowledge. But do we want a society where anyone can easily initiate lawsuits? The point is, these technologies have incredible potential, but the way we choose to use them will define the kind of society we create. The challenge is to think deeply about what kind of future we truly want and make deliberate choices about how to use AI to shape it. Okay, this is the last slide. When we think about the role of AI in our future, it's not just about reducing risks or maximizing industrial potentials. It's about the kind of society we envision, one that we shape together, involving scientists, engineers, business leaders, policymakers, and every one of us. Imagine a future where industries are not only more productive and efficient, but also truly sustainable, reducing our impact on the planet. Picture a world where AI empowers individuals, unlocking our true potential and sparkling creativity. As routine tasks are taken care of by AI, people will have more time to focus on what makes us uniquely human: art, relationships, and the experiences that give our lives meaning. This future is within our reach if we work together across disciplines and borders, guiding AI in a way that truly benefits humanity. I am very much looking forward to the discussion we will have in the next panel. Once again, it is a very great pleasure to have this opportunity to speak here. I would also like to express my sincere gratitude to everyone involved in organizing the Tokyo Forum. Thank you very much.
Thank you so much, Professor Matsuo, for bringing us up to speed on the latest on AI technology and the potential of AI for bringing a beneficial future. Thank you so much.